Lesson 5.1, the mean value theorem. All right, so this is what the mean value theorem says. Let f be a function that satisfies the following hypothesis. There's two parts to it. Part one says f is continuous on the closed interval a to b. I'm gonna draw a function maybe that satisfies this. Say it goes like this. There's the function. But it's continuous on the closed interval means that it is defined at the endpoints. So we gotta bubble it in. We're gonna have space for number 2. All right, so there's f is continuous on the closed interval from a to b. And number 2 says f is differentiable on the open interval a to b. So this is continuous here. But it only has to be, but then it has to be differentiable on the open interval from a to b. So if I draw the same function again, it has to be differentiable on the open interval from a to b. All right. If that is true, if this is true, then if this is true, then there is a number c on AB such that then there is a number c on AB open on open AB. This is very important here. This is on the open interval. Then there is a number c on the open interval AB such that f of b minus f of a divided by b minus a is equal to f prime of c. Let's see if I can say what, like, give you a real life situation example. Let's say that you during winter break, you and your family went on a trip to the coast somewhere. No, you went to where? Pismo. Yeah, you went to Pismo Beach. I don't know why, but you went to Pismo Beach. So your average, say you guys drove from Fresno. Let's go. How do you spell Fresno? Fresno. Here's Fresno. And then you drove to the coast, and so you got in the car, and you went to, and you went, and you average speed. Say your average speed, average velocity was say 65 miles per hour. So the average speed is 65 miles per hour. How do I get this number? Well, you just kind of go say, okay, this is 65 miles per hour. But at some point, for sure, this is what it's saying, which is kind of like, what is it saying? It's saying that, well, when you drove from Fresno to Pismo Beach, you did not drive at 65 miles the whole time. You weren't driving, unless you put it on cruise control, you were not driving 65 miles an hour the whole time. But at some point, you did drive 65 miles an hour. For sure, at some point. That's all it's saying. That at some point you did do that. All right. Let's see. Let's do an example. Problem number 1. For each of the following graphs, explain why the mean value theorem does not apply on the interval 1 to 3. Let me give you like 5 minutes to copy this down, and then we can discuss if the mean value theorem applies to this graph. All right, let me give you a couple of minutes. So let me give you a sentence frame on how to answer the question. All right, here. So on the AP exam, you would want to answer these questions that are open-ended like this, and you need to write down the answer where it makes sense and they would accept it. So here's the sentence frame on answering the question. The mean value theorem blank apply because the function f is on, okay? The mean value theorem. Does the mean value theorem apply to this graph? Yes or no? Anybody? Why not? It's not continuous. It is not continuous. So it will not apply because it's not continuous. Okay, so the mean value theorem does not apply because the function f is what? Not continuous, okay? On the interval 1, 3. On 1, 3. On the closed interval 1, 3. Yeah, that should be good. answering the question and explaining. Let's go to the next one. Quick, let's go B. And there's the sentence frame again. Again, you don't need to be copying this down exactly like how it is on the graph. Quickly, just kind of do your graph, you know, whatever. So on this one, the mean value theorem, again, blank applied because the function f is blank on. So it's already telling you for each of the following, explain why the mean value theorem does not apply. So we already know it does not apply. The mean value theorem does not apply because the function f is what? What's the problem with B? What would be the problem for this one? What is it? Is it the same? Isn't it? It's not continuous on AB. See, it's the same because it's, yeah. There's the problem right there. It's not continuous on 1 to 3. See, these brackets means that it is included. Let's see here, but it's not continuous. It's not continuous here. It would be continuous if it's bubbled in there. Then the whole thing is continuous. So it's not continuous. So this is not continuous on 1, 3. How about C? The mean value theorem what? Does not apply because why? It's not differentiable on AB. Why is it? Where is it not differentiable? Yes, it's not differentiable here because it has that corner and it's not differentiable. So, and connect this that the whatever the theorem says, not differentiable. Make sure you put open 1, 3. So differentiable with open 1, 3. Continuous is with closed. Kind of like they might have a problem with not doing it correct, stating it exactly like the way the thing says. And that's a lot of writing. Oh man, I should have told you guys, go ahead and go to the website and copy this down already. I had it open. So go ahead and copy that down. You know what I was gonna do? I was gonna do some matching cards instead, but I forgot. Okay, so here it says match each function with the correct explanation that would correctly determine if the mean value theorem would apply on the interval -2, 2 and why. If you guys, if this is too much to be writing down right now, you can go to the website and copy it down later. Why don't we just kind of answer the question already? Which one would go with which one? All right, let's go. Hey, let's take a look at this. Let's just look at it, and then you're gonna go after and then and copy it down. Let's take a look at A. The mean value theorem does not apply on the interval -2 to 2 because the function's derivative does not exist at x equal to 0. So the function is not differentiable on -2 to 2. So which of these ones the derivative does not exist at x equal to 0? Which one? 1, 2, 3, 4, 5, 6. Which one the derivative does not exist at x equal to 0? The derivative does not exist at x equal to 0. Whoa. Woo. Oh, dude. If we try to plug in this one and plug in x is 0, I'm looking at it. If we plug in x is 0, so that would be 0 times pi is 0. 0 divided by 2 is 0. Secant of 0. What's secant of 0? That would be the reciprocal. Secant of 0 is the reciprocal of what? So we can just say 1 over cosine of 0. But that should be fine though. What's cosine of 0? 1, so it's 1 over 1, no? That's no problem. That's not a problem. That's not a problem. Which one would it be then? No. No. If we take the derivative here, what the heck does ln of, what does this one look like? Well, if we do plug in x is 0. Okay, x is 0. Let's plug in x is 0 here. Well, what's ln of 0? Absolute value of 0. Ln of absolute value of 0 is still ln of 0. And what's ln of 0? Ln of 0, x is 0. Well, what does... because ln x would just be this function, no? Ln x would just be this function here. But ln absolute value of x is still not differentiable. It wouldn't be differentiable. I'm going to say this is it. What does it look like? You want me to go? I think it's going to look something like this. Let me put it in decimals. Ln absolute value of x. All right, let me put it into decimals. But I'm pretty sure that's it, though. But let me get out. Ln absolute value of x. Since break, this thing has slowed down so much. It used to be like quick. No, don't look. Close your eyes. Enter. No, enter. Slideshow. So I'm gonna say that a is 4. We could try this one. Why don't we take the derivative? No, this should be fine. This should be fine. The answer, I think, is that one now. What do you guys think? Anybody want to think of something else or what? Anybody? Is it or is it not? Am I the only one thinking here? Yes? Which other one could be? That is not differentiable at 0. It has to be that one. It is that one. A, 4, please. Oh, okay. No. I thought I got it wrong. No, I should still be fine. That should still be fine. I didn't do that one. Okay, so it's saying that. All right, let's finish it and see how many we get right. Let's do it like that. I'm saying that this one's A, no? Oh, I thought I had gotten it wrong. No. Did I stop the recording too? This is bad. I'm saying this is A. All right. So we got this. Let's go with B. The mean value theorem does not apply on the because the function is not defined. This one could be this. No. It is. It's fine. It's fine. It's not defined at x equal to 0. Which one would it be not defined at x equal to 0? Anybody? No, B is, this one is 4. Yes? It's not defined there. Is it not defined? I said that ln of 0, x is 0, ln of 0, and so if the graph goes like this, it will not be defined because it has an asymptote there. All right, let's go with C. Let's go with C. The mean value theorem does not apply in the interval -2, 2 because the function is not defined at x equals positive plus or minus 2. That's easy. It's not defined. Where would it not be defined? Anybody? C. There's nothing wrong. Like I was thinking it would be this one, but it would still not be nothing wrong with it. Does not apply to interval because the function is not defined. It is defined at 2. If you plug it in here 2, that would make it 0, square root 0, 0. There's no problem there. How can it not be defined? It's not defined actually. It is defined. It is defined. Okay, let's just skip it. We can't find it. All right, let's go D. The mean value theorem does not apply in the interval -2, 2 because the function is not differentiable at x equal to 1. Not differentiable at x equal to 1. Which one is it? Help me out, somebody. What does the absolute value function look like? Like a V. And it's going to be where? Isn't it shifted to what? It's shifted to the right one, no? So it's going to be some weird V like this, no? Yes? So would it be differentiable there, huh? So what are we going to do? D is what? We had already gotten it, remember? Let's go with E. Let's go with E. The mean value theorem applies on the interval -2 to 2 because the function is continuous. Oh, this one that it does apply. And even though it's not differentiable at x equal to 2, it is differentiable at -2 to 2. Not differentiable at 2. Hey, let's attack it a different way. Let's see if this one is differentiable. How do we test if this is differentiable? Take the derivative and evaluate it. So what's the derivative of this? And plug it in. 3x squared, plug in 2. So what is it? 12. And this better be 12, no? So take the derivative of this is what? 10, and you can't even plug it in. So this is not differentiable. 2, 2, 2, 2, and it's saying from -2 to 2. But it doesn't have to be differentiable at the endpoints. No. Not including 2. There's no problem at 2. See, there shouldn't be no problem at 2. It looks to be, do they connect? How about is it continuous? How do we test if it's continuous? Just plug it in. So what is it? 2 to the third is what, 8? This is 9, no? And what is this? 20 minus 11? So it's continuous, no? But it's not differentiable at 2, no? It is continuous, but not differentiable. Let's go with F. The mean value theorem applies to the variable negative 2 to 2 because the function is continuous and differentiable. Okay, this one is that it is just continuous and differentiable everywhere. It satisfies it. Which one would satisfy everything about it? So one about 0 not being differentiable at 0. If we graph this one, let's go back to this one right here. What do you think a fifth root of x looks like? We need a graphing calculator though. Take the derivative. If we take the derivative of this, if we take the derivative of this, what would it be? K prime of x, what would it be? 1/5, it would be 1/5, and then what? 1/5 minus 5 minus 4. Yeah, and this is x, and then to the 5th. And you plug in 0 here, that'll be 1/0, be undefined. So at 0 is not. So this one is not differentiable at 0. It does not exist at 0. So this one would be would be 8. Yeah. And so we're missing the last two. So which one? We already got what? We're saying that this is A. And we're saying that this is D. We already got D. We got E. And we got B. Okay, so for the last two, how is it not defined? This is F. If we plug in 2 here, we already did it. We plug in 2, we're going to get what? 2 secant x. So 2 divided by 2, that'll be secant x, wouldn't it? So this will be secant x of secant x. Hold on now, what am I doing? This is x is 2. They cancel secant of pi. What's secant pi? What's secant pi? That would be the what? The reciprocal of what? 1 over what? Cosine pi? It does exist, huh? It exists because it'll be cosine pi in what? Negative 1? 1 divided by negative 1 is it exists, no? So it exists. So which one is it? It exists. F is this one. Let's get it done with. Let's switch them. How many did we get right? How many did we read? All right. So let me give you the answer now. How many did we get right? We had it right the first time. Enough of this. Let's go. Move on. Let's go to number 3. So now something that is more mechanical. More procedural. Let f of x equal this quadratic function on the interval from -2 to 4. find all the numbers C that satisfy the conclusion of the mean value theorem. Can we apply the mean value theorem to this function? Can we apply the mean value theorem to that function? Yes or no? Why yes or why no? What are the two requirements? What are the two things that it says? It has to be what? It has to be continuous on AB. It has to be continuous on closed AB, and it has to be differentiable on what? On open AB. You know, that's it. That's all we. This is what the theorem says. It has to be continuous on a closed AB and differentiable on open AB. That's what it is. All right. So this quadratic function is continuous. Yes or no? Any quadratic function is continuous. Yes. And it's differentiable on negative 2, 4 because what's f of negative 2? You're going to get a number, and f of 4, you're going to get a number. It is continuous, it is differentiable, and we can go ahead and apply the mean value theorem. Let's go ahead and apply it. So how do we apply it? What is the mean value theorem? It says that what? F prime of C, there is some f prime of C that will equal to f of B minus f of A, B minus A. What is A? Negative 2. So let's go ahead and just plug it in. This is let's plug in. Let's call this this is A. This is B. So B, let's put 4 minus negative 2, and we're gonna do f of B, f of 4 minus f of negative 2 equals f prime at C. So now let me go ahead and already do this one here. Let me erase it. Let me erase this, and we're gonna take the derivative of this function and put it here, because we'll be writing too much. That's what we're doing, no? Let's go. So what's the derivative of this function here? 1/2 x. That's it, no? Oh, it's just 1/2 x. All right. It's 1/2 x. Let's go with 1/2 x. Yes. All right. So 1/2 x equals 4 minus the negative 2 is 6. What's f of 4? F of 4. Plug it in here. F of 4. 4 squared is what? 16. What's a fourth of 16? 4 plus 2 is 6 minus f of negative 2. F of negative 2. Negative 2 squared is 4. A fourth of 4. 1 plus 2. So this is going to be, okay, now, look, it's saying find all the numbers C that satisfy the conclusion of the mean value theorem. This C right here is this x. So it's 1/2 C. X is the critical number. So let's go here and say 1/2 C equals 6 minus 3 is 3 over 6. And C is equal to what? It's 1, isn't it? Because like half of 1 is half here. So, or whatever you want to do. Yeah. So C is 1. And that's it. Find all the numbers C that satisfy the conclusion of the mean value theorem. C is equal to 1. And let me show you what it looks like, everybody. Look, the graph of f, this graph of this quadratic is right here. I'm going to show it to you right there. That is the graph of f. And it's from negative 2 to 4. From negative 2 to 4. And it's saying that This is the average rate of change. This is the average rate of change right here. And you're trying to find out where is the average rate of change the same as the instantaneous rate of change here. It wouldn't be here because you know that this is not the same slope as that. It would be somewhere here that it would be the same as this. And it looks to be at 1, of course. And if you do it, they're going to be parallel. That makes sense? Yeah. So at this point C, which is x equal to 1, is where the slope of the instantaneous rate of change here is the same as the slope, the average rate of change from A to B. All right, let's go to number 4. And I think this will be it for today. And let me give you a sentence frame. Problem number 4. Let G be a differentiable function. Is there a number C in the closed interval from -5 to -3 such that G prime of C is equal to -4? Justify your answer. The mean value theorem blank because the function is blank on the closed interval. Yeah, you guys are copying it down. From the beginning, how do you know that you should continue and continue working on this in applying the mean value theorem? What gives it away that you should use the mean value theorem? Anybody? In the statement, in what's there, what gives it away that you should, that the mean value theorem applies? What gives it away? Differentiable is correct. The minute it says let G be a differentiable function, you automatically apply the mean value theorem because differentiable automatically is going to be continuous. So differentiable is more powerful of a word than continuous. If it would have said let G be a continuous function, is there then you wouldn't apply the mean value theorem. But once it says it's differentiable automatically is continuous. So yes, we will apply the mean value theorem because it says it's differentiable. So the mean value theorem applies because the function is differentiable on the closed interval -5 to -3. So now we are going to go ahead and apply the mean value theorem. Okay, so how can we, from the given information here on the table, from -5 to -3, we have to figure out if there is a average rate of change. What we're going to do is average rate of change here that equals -4. Is there an average rate of change that we can get from either getting these ones or this one until you get -4? So we're doing what? F of B minus F of A, B minus A. And let's use what's given. Let's use let's call this A and B. So let's go with what? -3. -3 minus a -5. And then we're going to do F, which is not F, it's G in this one. G of -3 minus G of -5. And what is G of -3? What's G of -3? So it's going to be 2 minus G of -5. What's G of -5? 10. And then you got -3 minus a -5, which is a plus plus. That would be 2. -3 plus, so then you got 2 minus 10 is what? -8 over 2, which is what? So there it is. So there is, on the interval from -5 to -3, that average rate of change is -4. If you did not get any kind of -4, you could have, yeah. So since we did get that -4, this is a differentiable function. There is a C value. So here's the sentence frame for it. All right, there. We're going to copy it down. It says, by the mean value theorem, blank, on the blank blank, such that. So how do we justify the answer? By the mean value theorem, what do you think it goes here? By the mean value theorem, there exists a C value equal to no. There exists a C by the mean value theorem on the interval, on the closed interval, on the open interval, such that all right, here it is. By the mean value theorem, there is at least one value C. By the mean value theorem, there is at least one value C on the closed interval. Is that what it was? On the closed interval from -5 to -3. Let's see, what do I got here on this one? On the open interval. So okay, so it says by the mean value theorem, there is at least one value C on the open interval. So it says C greater than -5, less than -3. Okay, this is absolutely important right here, because it's always on the open interval there will be a C. It cannot be at the endpoint. So the C value has to be in between A and B, and it cannot be at the endpoints. So it has to be inside of it. Make sure you remember this. By the mean value theorem, there's at least one value C on the open interval. Such that what? What? Such that what? F prime of C is equal to -4? It's not F, it's G. G prime of C is -4, yeah. So yeah, if you can practice, I don't know, we're gonna practice writing this correctly because they're very demanding on exactly the wording on that when you take the AP test. That this will get you passing, hopefully, score. And that is all for today. All right.